next rule we're going to cover is the quotient rule. So, in the quotient rule, if we have a term raised to a power over a term raised to a power and we have the same bases, we can write it as that base raised to the difference of the two exponents. So in the first example here, like we did last time, we'll go ahead and use the formula and then we'll try and justify it without the formula. So the base that I have in common is 5. The power on the top is 4. The power on the bottom is 2. So I get 5 to the 4 minus 2, or just 5 squared. Now let's try and think about this a different way. 5 to the 4th is the same thing as 5 times 5 times 5 times 5. 5 squared is the same as 5 times 5. So, knowing how division simplifies, for each factor that I have matching on the top and bottom, I'm allowed to get rid of those. So I can cross those two 5s out, and I can cross those two 5s out. And if I count how many I have left, I just have 5 times 5, which is 5 squared. So essentially, the subtraction that we get in the exponents is the same as the algorithm of crossing out the matching factors. So let's try the next one. So here we have z to the 6th over z to the 3rd. So if I use the rule, that's z to the 6th minus 3. 6 minus 3 is 3, so I get z to the 3rd. And if we think about it, using our same reasoning, in example 1, z to the 6th is z multiplied by itself 6 times. Z to the 3rd is z multiplied by itself 3 times. So when I cross out the ones that I can get rid of, notice that I only have 3 z's on the top, which is z to the 3rd, which is the same thing I got using the formula.